So,
I think in your message you had a start.
So it says like 6:50.
Okay.
I'm very flexible with doing whatever I want.
Literally or
I do not bend over. Thanks everybody for coming. Thanks Jay for speaking. There's nothing worse than preparing a talk and having 5 people come. Thank you for coming. And we just have to all make up for it by going to your meetup.
Yeah.
That's how we make up for it, and we just go attend your meetup next week.
Exactly.
So which you're more. I'll give you more floor to plug in a minute. Everybody's been here before you get, so I'll go through my normal thing. We're sponsored by the Ford Utah Foundation. We have a Slack group. You're more than welcome to join. The website's fordutah.tech. And then there's just a link that says join Slack. We've got great communities where we talk about AI too much and data engineering. We've had some really interesting threads in anti-AI where we bike shedded yesterday on what it means to be a quad bro versus use quad. That was interesting. It was very interesting on whether or not quad was good at their job. I mean, Anthropic was good at their job, or versus if they were mediocre. And I was just like, everybody, it was great. It was very entertaining.
I saw that. It was very good.
Very entertaining. All right. We have a jobs board where we post jobs and then people wanting jobs. Jake posted jobs. I do not post jobs because I'm not hiring until. I don't know. They keep telling me next month, and it's been 9 months.
I've applied to jobs where they've come back and said that. So
we also have a great channel called Local Events for like pretty much anyone that runs a tech event in Utah. That's what we're doing. Next week we have the MLOps meetup, and the speaker has never gotten me entitled. And then Jay's meetup's also next week, which you have as title and a speaker.
Yeah, actually I have it up here. So our meetup is about using AI to build software. So AI-driven development. We have a person who's an ex OpenAI employee coming to speak next week, and I think it should be good.
And the fact that it's out in Beehive is great.
Yep.
That's where I work. So.
Yep, school AI.
I have no excuse. I'm literally sitting there in my desk when it starts. Everything you did it twice. I've been sitting in my desk when it started everything. I just had another meetup at the same time. FordUtah.tech. That is the website for the Slack group where we have all the fun conversations. I'll kind of over to Jay. Hopefully you can reaffirm my opinions that Avro sucks and nobody should use it.
So we're gonna talk about Avro and how great it is today.
I don't like Avro, but like Google for some reason has decided it's BigQuery's best friend, and I'm just like, why? You invented Protobuf. Why did you choose Avro to be BigQuery's best friend? I don't have any actual case of Avro. It's a double ecosystem type.
Yeah, I just love Parquet.
No, those are not mutually exclusive.
They will. At least they used to.
They play well together the same way it does with BigQuery because somebody decided to make a nice package. I've only done Kafka with Protobuf, so yeah. Anyway, sorry.
No, you're good.
Rails. I just want you to know I have a bias.
All good. We can have biases here. You can be a Avro bro or
An Avro bro.
a user. So I'm gonna start with a little bit of I guess kind of theory, but pretty basic stuff. So columnar versus row oriented. I'm sure you guys know this. What's the difference? Why would you use one versus the other?
I want you to know I had a job interview where this was the only technical question. And the fact that this was the only technical question made me feel like it was a very low bar of entry for being a data engineer.
Yeah.
So do you want me to answer it?
Sure, go ahead.
I did pass. I passed the interview. My answer at the time, which is amazing, that it applies. I said it basically at the end of the day, it has one of the biggest things is that you're going to have a difference in how you read the data out of the database. You have how it's stored. It's just that Snowflake doesn't store them that way. These are just bigger, but whatever. They're still columnar. Right? In row-oriented databases, when you scan the entire row and then you select what you want out of it. Whereas in columnar databases, they select the columns you want and then you scan the rows after that. If you want to go into efficiency, for small numbers of rows, and small is relative because what is small? It's less than a billion. Row-oriented tends to be faster. Or column width is also a dependent thing. The more columns you have, you tend to get advantages from columnar storages because you can do smaller stuff. Anyway, but at scale, and scale is data size, not at request size, you get efficiencies from columnar.
Yeah.
That was my definition in my job interview.
If you have control over it, trying to find what are you pointing out as being important? Is it important for specific data in each column, or is it important all of the data together for each?
Yeah, it depends on your use case, what you're looking at, what you're looking for. Do you need all the columns? Do you need just certain columns? That's very important. I just want to bring a couple of advantages of columnar storage. First, because things are in columns, they're easy to compress. So because of the same type of things, whereas rows, that's much harder. You can grab only the columns you need. You can take advantage of SIMD, single instruction, multiple data. Everyone know what that means? Basically, an instruction in the CPU that says process 4 columns at once, or four data points at once, or 8 data points at once rather than 1. Also, you can do predicate pushdown. So let me show. Let's see. I'm sure that changes constantly. Oops. Let me show an example. Oops. Okay. So we have columns in a typical columnar database or columnar format. You break things into chunks, and this is simplifying things quite a bit. But within each chunk, you can compress things certain ways. So you might have one chunk compresses very well with dictionary compression. Another chunk compresses very well with bit packing, and each chunk can be independent. You can make very efficient use of space that way. There was another point I wanted to make. Oh yeah, predicate pushdown. So predicate pushdown just means we select all rows that are greater than purchase amount greater than 5,000. We see this chunk, the maximum is 2,800. We don't even need to look at it. We can just filter it out. Whereas these, we might have to look deeper into the chunk to see if there's rows that satisfy that constraint. So, all right. So with data formats, we have encodings and codecs. Codecs are pretty simple. I'm sure everyone's seen these. Snappy, LZ4, Zstd, Gzip, Brotli. These are common, but supported by different formats. What you want, if you want really fast decompression, maybe you want Snappy or LZ4. If you want really good compression, maybe you want Zstd or Gzip or something, or Brotli. Depending on what you want from your data, that's what which codec you should use. Encodings is a little bit different. That's actually how you're going to compress the data. Actually, I said up here. Encoding is how you store the data. Codec is compression on top of that. So dictionary compression, we have a car data set, our auto data set. We have make and manual shift. These are strings, so let's say 2 bytes per character, 12 bytes for each of these, 4 bytes for each of these. We could also just put an array of each of the values and say Toyota's 0, Nissan's 1, Volkswagen's 2, and just store the integer into that array. That's dictionary encoding. Next step is bit packing. We just have 0 and 1. We don't need a whole 4-byte number to track that. We can just use a bit, for instance. So bit packing says, let's just use a minimum number of bits we need to actually store this data. And of course, run length encoding is very popular. We have all these blue colors in a row. We say, let's say there's 6 blues, and then there's 8 reds, and then 20 yellows, rather than store each one individually. So I'm sure this is pretty basic, but any questions there? Okay. So one thing that really makes a difference when you store data like in Parquet, for instance, is a sort order. So for instance, how many things are in a row, the actual just the shape of the data really can be affected by the sort order. And it's really hard to predict. This is a file I created, random order. It was 6 gigs. I sorted, but this is a weather station file, so weather data file. I sorted by time and then station. It was 2 gigs. I sorted by station, then time. It was 800 megs. So that really makes a big difference in how big the file is. So I mentioned cost, or we mentioned cost of the tax or whatever. When I think of cost, I think of file size, how much data you're sending over the network, how much data is going to the CPU, how quickly you can access the data, how latency to get to the data, that kind of thing. So sort order makes a big difference. Let's talk about formats. Of course, there's the old standbys, CSV and JSON. I created a vehicle for each of these. So CSV is like the, yes.
I know that doesn't.
Well, I mean, you can do CSV over SFTP, but usually people want to give you both, and that's just disgusting.
I should rephrase my hatred of SF and CSV.
Yeah. Agreed. Yeah. So,
But CSV is probably the most common format out there because it's everywhere.
away from it, it's like very effective.
It's very easy.
It's just.
It's easy to understand.
Yes.
So it's easy for a human to understand.
Yes.
That's what I mean by effective. Like you'll find it a lot of times you get it from the non-technical individuals.
As long as they were.
The problem is my problem with it is data integrity. So
Oh, and it's just problems.
yeah,
Like,
there's everything in the stream. Everything is you have to
And I've had more than enough times where don't.
Just give me the JSON is essentially where I'm at.
Something I do is if I have to fill out a form, but I really don't want to fill out, you're collecting data on me, really don't want to do. For some of my entries, I put every single blue in there that I can, so that if it were ever exported into Excel.
That's great. Love it. So CSV is your Toyota Corolla, old standby. It's been around forever, ubiquitous. JSON's your pickup truck. It's more flexible. It's also bigger and less efficient in terms of space. Yep.
Why I said give it.
Yep. But it is the standard format for APIs. Many dashboards, despite they're trying to send lots of data to the browser, they're going to send it in JSON or even from the server between servers in JSON. The row-based, of course, Avro is the best. seriously, there's a difference between Avro and protocol buffers. They both have their strengths. I'm saying Avro is like a semi-truck, protocol buffers, or I should say a fleet of semi-trucks, protocol buffers a fleet of courier bands. Avro, the big difference is the schema is embedded. So that means you set the schema along with the data. It's easier to look at by some third party. Whereas protocol buffers, you have to compile that into the schema or into the file or into the binary, or not in the binary, but the description. And then your client server has to basically match, or else you can't communicate. Use case, streaming data, data pipelines, APIs. This is much better than JSON would be. Columnar data. This is probably a data format we'll have us work with a lot. Orc is mostly for Hive, Trino, Presto, AWS Athena. Parquet is pretty standard across data lakes. I said a cargo or a container ship and a cargo plane for these two. Parquet is the industry standard for data lakes, I would say. It's great for when you're storing and transporting large amounts of data. Then you have some engines. DuckDB is basically a full database you can run in the browser and the server, wherever you want to run it. It's a smart logistics hub. Arrow is just a jet engine. It's made for pure speed. Because of that, they sacrifice some compression. Any comments? Are these a fair assessments?
I was gonna say Apache Arrow, I switched to support Parquet as their default over the wire.
Mhm.
They used to have, I swear, when I first looked at Arrow, they had their own format, and then they're like, no, and they use Parquet, which is why that is now my preferred.
I think they should.
For data transportation, but no, I don't use it. I use JSON. So
Yeah, Arrow and Parquet are used a lot together. I think Arrow actually has two different formats. I forget what
they do.
Yeah.
They do have multiple, but I've noticed them lean more towards Parquet.
Yeah.
Recently, just especially as Arrow becomes like a protocol. Arrow, I know Iceberg uses Arrow. So it's becoming more like a protocol, and Parquet is like the underlying file format.
Yeah.
Whatever. I don't feel it's not whatever. I'm sure there's intentional reasons for it, but BigQuery thinks that they should use Avro, but all their data is actually stored in Parquet.
Mhm.
Great. I tell people to use Parquet all the time, and then you just load it into DuckDB, and you're good.
Yeah, Arrow is the engine. They also have Arrow Flight, which is more like the protocol. It's like a replacement for
So they
JDBC.
just fork it instead of having me.
I mean, I think it's the same.
I don't follow it that closely.
Yeah.
I just know that once upon a time I looked at it, and then occasionally I'm just like, oh yeah, remember Arrow, that cool thing that lets you do stuff?
I don't think it's a fork. I think it's more of like a different sub-project. Yeah.
Okay. I've never really worked with Apache.
Mhm.
Can you help me understand your analogy between fork is the internet, Parquet is the cargo plane?
Yeah. Just that they're both for sending lots of data, and that's really the whole point. They're both for sending large amounts of data. As far as the specifics of a boat versus a plane, I don't know if I have a great analogy there.
Is fork slower than Parquet?
We'll look at that later, but I'm not sure if it's actually that much slower. It might even be faster in certain cases. And I will say, for one thing, benchmarks are hard, and I do have some benchmarks we'll show later. But I would say Orc and Parquet are relatively similar, the same ballpark, at least. Both. They do similar things under the hood. Yeah. Okay, so Parquet. One of the things about Parquet, I'm going to focus now more on the columnar side and Parquet specifically. One of the things about Parquet is when you're creating a Parquet file, there's lots of options. And you almost have to be an expert at Parquet to understand what to do. So column types is obvious. Sort order, that's pretty easy. Codec, that's not that bad. Encodings is basically how you're going to compress each column. There's a row group size and data page size, and those all can affect the size of things. So here's a Parquet file with different encodings. We have Snappy, the Snappy codec, and plain encoding, when plain is basically no compression. We have a LZ4 with the default encoding, Z standard with the default encoding, and then Z standard with delta encoding, and that's only specific columns. That, probably wouldn't need to get the details of that, but basically, just the point is how you set the parameters of the file makes a big difference in how big the file is, which again goes back to cost. So this was a 235 million row data set. This is actually the same data set, the weather data set. So we range from 4 gigs to under a gig, depending on the parameters you set. Parquet encodings, we talked about, well, plain is just no compression. RLE, run length encoding dictionary, we talked about that. Delta binary pact, I probably won't get into the details of these too much, but I do have a project that I created recently. I call it AutoPark, as in Auto Parquet. The idea is it lets you figure out what the best parameters to use on that specific file would be. So it has explanations of each compression algorithm, and then I have it here. Oh, I might have closed it. There we go. So the idea, you just drop a Parquet file on there. Let's choose this one. It's going to analyze the file. It's going to look at the different column types. It's going to look at the structure of the data, and then basically recommend which compression type you might want to use for any given column. You can actually download it. Well, first there's code at the bottom to actually create the file with those encodings and yeah, those encodings. Then we can also actually just download it and optimize a copy of it. So I'm curious, is that something people do you actually do this, look at the encodings at all and change those at all, or just kind of skip the defaults?
I've never gotten far enough in a project where somebody's like, this takes up too much space.
Mhm.
Usually I get to the point where they're like, you spent a year on this, why doesn't it work yet? And I say data is hard, and then I go find a different job. So no, I have not hit that point in my career yet where that matters.
Mhm.
That being said, I do tend to tell people you should tend to store it in Parquet and look at doing or something that is encode, like Zstd. We did a lot of Zstd at Tailscale because my coworker really liked encodings. It was like his thing, and he said that was the best encoding package he had run into at the time, and he just did JSON into Zstd. So no, I haven't done it, but I just tell people use Parquet because it does a really good job out of the box, and it, like I said, like it loads into like DuckDB or really any database really well. So like I make recommendations. I don't mess with encodings because I don't. Yes, my tenure's never been long enough for that to matter.
Fair enough. Yeah.
Slightly embarrassed to say it. Never really thought about it. Just kind of said, sure, whatever the default is, good enough. But
it matters with Kafka though, because if you persist, it could theoretically matter with Kafka.
depends on if you're doing Kafka. Well,
Whatever you want, Ava.
encodings also math.
Oh, for Ray, I can imagine.
What's Ray?
It is a distributed computing,
Gotcha.
like, I like Kubernetes, but it
Yeah.
runs a lot more in Dask and other data processing jobs. I use it for distributed VLLM, so that it comes in a lot with that now, but it is like it is a distributed compute framework. It's not Kubernetes, but it is a clustering.
And what's the time you should? What's at Parquet? Really.
And then it would.
Yeah.
There are all these things coming up, Arrow and Parquet. And, I'm glad I haven't missed it. Yeah, I could imagine Ray. Ray is one of those things where it's like, it's a Ferrari, and so if you don't tune it right, it doesn't work.
Yeah.
So,
And I would say this is probably more of a problem at scale when you get to really big scale. If you had on much scale, who cares?
occasionally with DNA and whatever genomic stuff occurs, you might have a little bit of big data.
And
For sure, yeah.
Yeah.
Just a little bit of big data.
like RNA.
But just the kind of point of this is looking up, not that one. Yeah, where it was. Oh, yeah, here. So you can see that it really does. It does make a big difference. The codings, the sort order, all these things can make a big difference. It depends on the data set. Not every data set's gonna make a difference on, but it certainly can. Okay, so we showed that. So I'm actually working on my own data format called, I'm calling it Neutrino. I'll probably need to change the name at some point. I plan open source. It's an alternative to Parquet, Arrow, and DuckDB, but I'm aiming it at in-browser analytics. So my goal is to find the sweet spot between compression and speed. I said that Arrow is really fast, like insanely fast. Parquet is really good at compression. I'm trying to get something in the middle. And again, something that will work well in the browser. So I said a space.
Browser that you plug in all of your data into the browser, pick it up from a website, or you're talking about like Google Analytics type browser?
I'm talking about a front-end web app that can process your data in the browser without a server.
No, you should talk to Derek. Sometime I'll talk about this. He has similar needs.
Really?
For his surfacing of data. Yeah.
Okay.
Anyway, I'm saying you'll probably have similar problems with that. And yeah, there's a lot of need there. I agree with you, especially if you want to do any chat-based analysis. Having to do server calls is going to have a lot of latency issues. I think that's a great space that's becoming more and more relevant as people want to just like explore a subset of their data.
Mm-hmm. Yeah. One thing I forgot to mention. So I mentioned all these parameters you specify in Parquet, and this actually the same with ORC and all these other formats as well. I try to get rid of that as much as possible, and just humans should not be optimizing encodings in data files, in my opinion.
I agree, but I've never done it.
And it's not like many people haven't done it here either. So you're just leaving stuff on the table. Yeah.
Your database in the cloud, which is more expensive space, because it's a trade-off of making more CPU to compress, that costs you more than just.
Yeah. So generally, CPU is going to be more expensive. I mean, storage is relatively cheap. However, you are dealing with more bytes, so that could also make CPU more expensive as well. So if you don't compress it as well, so that can be a thing. Or even worse, the CPU is waiting for data to come from the network or from S3 or wherever, and that takes a while, and the CPU is just sitting there waiting for the data to get there, doing nothing. Good question. So Parquet versus Neutrino, I mentioned I'll use parameters you guys specify. Neutrino, I just specify the column types, sort order. And then I could just default to Zstd.
Which is, like I said, my former coworker said was the best, so therefore it is forever the best.
It is pretty much, it is one of the better
I
ones today
trust
for
your
sure.
Opinion implicitly, like, I agree. I think that's a fantastic. You have my uncertified stamp.
Thank you.
Unqualified stamp.
Even though I'd said good things about Avro.
I'll give you a pass. I know you're trolling me.
All right, so let's look at a demo. So this is a serverless dashboard I'm writing. It's running 100% in the browser, and just to prove that, I'm going to set it to work offline. Whoops, not there. Ah. Sorry, having issues. There we go. So work offline. You can also see up here offline. I've got some files here. We'll take that file. Uh-oh, that's not good.
Yeah, the browser's offline. Oh, yeah, because it's a Google Meet.
Oh, it's a Google Meet. That's not gonna work, is it? Yes, good point.
We believe you.
I should have thought that more through.
I don't think there was anything to think through, which validating that technology works.
That's right. Now can I find Meet?
We can definitely take you at your word.
There. I'm back in line. Yep. But trust me, it does work offline. All right, so I've got some files. We're gonna just drag into the browser. I guess you can't see my file explorer either, but that's all right.
Do you have your volume on?
Oh,
There was a slight echo by me.
Yes.
is that better?
Yep.
Nope. Let me simply mute myself.
Is it live? No, it's.
There we go.
Okay, thank you. Sorry.
Okay, we'll see if the demo gods actually work with me today or not. Actually didn't like that file, so I'm gonna try a different one. This is still a work in progress. Let's look at. A specific file I was going to use. Let me find it. There we go. So we're going to look at New York taxi data. So I loaded a Parquet file into the browser. It's using DuckDB under the hood. We have the data loaded. Let's change what we're plotting. Let's look at. Let's see. I think they have date. Yep, date. Let's do pickup date, and then fair amount. So it's pretty responsive. This is 41 million rows, all running. It's all running in the browser.
Small data.
Small data. Yep. This is a Parquet file. Let's do my custom format, but we'll go a bit bigger. Yeah. This is flight data from 2020 to 2025. We're gonna just drop it in the browser. 134 million rows. So this will take a little bit longer, but there we go. 93 columns, 134 million rows. There's a lot of columns. So luckily, this is columnar, so we ignore most of those columns. Let's look at distance over time, and then also group by airline. There we go. So the point isn't that this is really fast, but it's 134 million rows. We've been crashing thing. It's all bringing in the browser. I'm going to go one bigger. This is weather data. I can find the right file. Yeah.
This is what kind of program are you doing data?
Yeah, so the browser has a database built in, has a couple of them actually. So it's storing locally. It's not cached. There,
It's in the browser tab.
it's in the browser cache. Yeah, yeah, yeah. So we just loaded. This is 200.
Goodbye database.
Well, so the data is actually stored in IndexedDB.
Yeah, I understand.
Yeah, yeah.
I'm just being
Yeah.
easy.
Yep. So let's do average. This is weather data. Look at temperature over time. 100 years of data, 235 million rows, not 10 columns. So we can handle both very tall files and very wide files, and it works. So again, this is because of the data format. Because we're compressing this data, I can make it much cheaper to compute on all that data. Let's look at, so here's the airline data set. This is a smaller data set, 18 million rows, 94 columns. Quick dashboard that came up pretty quickly. Let's filter on flights arriving before noon. And we update the dashboard pretty quickly. Any thoughts, any questions? Yeah.
What if I want to put it
So
I'd love maybe a little less.
it's actually a good question. Go ahead.
Oh, I was gonna say, do you have the ability to, how quickly can you show the top 10,000?
What do you mean by the top 10,000?
So, or say your upper left, you know, you have
Mhm.
certain data points.
Mhm.
Let's say you click into.
It doesn't actually let me click. Just take a mouse over.
Let's say I want to, you know, you're showing aggregate data.
Mhm.
That image is going to.
Yeah.
It's 1,000 records to fly into the airport.
Yeah.
How well does it handle something?
So I think what you're saying is, what if I actually had a lot of data points rather than, like, this is actually a fairly small number of data points we're plotting on. Yeah. So I don't handle that use case yet. That's something I do want to handle in the future though. And that's something you could handle. So the backend or the code base behind this is Rust running in WebAssembly. And so you could basically write or draw straight from WebAssembly to the canvas in the browser. That should work. At least I haven't tried it yet, but that's one of my goals for the future.
Oh, I'm just noticing the way you're rolling out is like.
Yeah. Yeah. So again, I've taken something that's quite expensive. Typically, you probably have to do this on a server, and now I'm doing the browser because of these file formats. Ultimately, so one thing I will show. Let's look at a data set that's already there. Let's look at the one we just looked at on the dashboard. So here's the actual data. I can scroll through the data set. Whoops. All 18 million rows. Just to show that it is right there available. I can filter. Let's look at just SLC. So it's quite efficient. So just to give this context, speaking of Excel, they have a limit of 18 million rows. I'm sorry, this is 18 million rows. They have a limit of 1 million rows, and good luck actually getting 1 million to work. You have to wait. It just have to wait forever. Google Sheets has a limit of like 10 million cells, so basically 1 million times 10 columns. Most dashboards, they have limits of like 10,000 data points on the client side on per chart, or maybe tens of thousands in some cases. So basically, all your commercial dashboards out there can't handle this much data. And unless you do something like with DuckDB, I mean, I showed DuckDB earlier. It does the same kind of thing. But then you have to develop it yourself. There's no commercial tool that a business user could use to do that. Any questions?
That's cool. I like your demo.
Where does AI fit in?
So I actually used AI to build this.
Oh,
So yeah, so in this case I used Claude to show what the format under the hood looks like. So I was talking about Parquet, but this is actually the neutrino format. Although it's probably changed a little bit since this was created.
If you were a PBI output whatsoever, why haven't they taken this?
I don't know. I've been wondering that for a while, to be honest. This is actually a project I've been working on for like 10 to 15 years. It's morphed over the years, and with just last year, I wanted to get into using Claude and code and tools to see how they work. So this is the project I use it on, and I was pretty impressed with what I could do, which is why I started the meetup. So this is actually not that hard. Like you can do it today with tools like DuckDB. So I don't know why they don't do it. That's a very good question.
Watching this talk, I've never seen that.
I will.
Calls over the wire, right? This is 100% mobile.
Yes, that's part of it.
No, I'm agreeing with you. I'm saying the latency is expected with that. I think the reason they don't do it is going to be a control thing. How are you gonna, you can give somebody a website, they cache everything, and then their computer loses things. Like there's an end user experience and debuggability and control that they wouldn't have. They'll say this is a you problem versus a us problem, which is, again, I think the reason that like your Tableaus and your Power BIs are not going to ever end up doing that. But I do see things like teams, that Zstd model, where you might have some scrappy analysts who could enable by Claude do something like this in like an intranet or behind the gate route for an internal company. So then you wouldn't need to pay for those executive dashboard style tools. You can just be like, hey, great, go to an internal thing. So I don't think you'll ever see it in a large platform because of experience and control. But I do see again, you have a scrappy analyst that wants to do something that's just plain incredible. Yeah.
That's where my head's going. Because you're right. I think I work for we are more into this is the sort of thing that I'm close to here. Because you can build yourself. If you could build something faster and better, out spending thousands of dollars on it, why wouldn't you?
But you're going to have an experience at the end of the day. You're going to have your CEO that says, I want to click a button and see it, not say, oh, but what if it doesn't work when I click the button? And I think that's always going to be the argument for the staff. That being said, I'm not saying it's a worthwhile argument for the staff. I'm just saying there is one.
Yeah. No, you're getting into the support side.
100%. That's the only. If they're at home or they're traveling in China and want to do something at your 3 a.m., like Power BI can win.
True.
Right? But
we'll save it for.
Sorry, I was.
But it's a very long way of saying this. I can see some internal development teams utilizing for their get rid of expensive external sites.
And let me add some caveats. Part of me thinks I'm trivializing how difficult this is to do. Like my background's in performance. I've done so many years learning performance techniques, and I've applied them all here. So
We're not trying to minimize your expertise.
Yeah.
What we're saying is the stack that you use specifically.
Yeah.
If you were to, especially with Neutrino and like DuckDB and the browser, it's a powerful stack for enablement.
you can get pretty far with just DuckDB by itself.
Yeah, that's the point.
Yeah.
Like, there's an incredible enablement there. Nobody's saying they're going to be doing a 13 million row, whatever
Yeah.
size thing at that scale, but it's still an incredible enablement thing to say, if we just want fast analytics that are super performant, not laggy,
Yeah.
you have a great stack here for prototyping it.
Yeah. The other thing is so I am kind of cheating as well. Like that airline data set that's I think it was 115 million rows. It is a 3 gig file. So downloading that over the internet, over the network could take a while. So it would not be as fast if it's not right there on your machine.
Situations, cheating.
Yes. Yeah, exactly. And that's really the use case that this is kind of best for. So there's a big thing to do in Power BI or Tableau. Is that maybe you have another build that then updates the data or something. So here's some actual numbers. So this is the NOAA weather data set. So 25 million rows. So 5 gigs as JSON, 1.3 gigs as CSV. I get it down to 84 megs. 65 seconds for me to load the CSV into the same GUI versus 1 second with my format. And 236 million, 52 gigs is JSON, 15 is CSV, etc. So data format is what really matters. Is kind of the point of this.
I like the flash code.
Yes. Good luck with that. Any questions before we move on? I've got a couple more slides to show, but okay. So here I'm comparing different. Actually, let's just go. I built a little app to compare different sizes. So run benchmarks in these different files, compare the sizes. So this is native. Let's look at 10 million. Let's make that bigger. There we go. So obviously no code or no codec is going to be the biggest. So let's take that out. So you can see, relatively speaking, the different codecs versus the different formats. So question was asked about Avro and Orc. Avro is a little bit bigger than Orc, so Orc might be a little bit better compression. Again, I'm focusing on really small files because I need to get them in the browser. And I have this special algorithm I've created. It basically figures out, is Zstd good for this column or something else better for that column? So I get much better compression on certain files, at least with that. Performance. So you notice my write speed is actually pretty slow. That's because I'm doing more optimization at write time. And then I also haven't optimized the write very much at all yet. So I probably could do better. And I will say benchmarks is hard. So I won't when it trusts all these numbers exactly. I bet arrows actually can be faster and probably have a bug there. Here I'm looking at size versus how long it takes to do these different things. Read, write, query. And this is native. Let's look at WASM or WebAssembly, which is the browser. Same kind of thing. So running on your machine versus running in the browser. So DuckDB actually is fairly performant, generally speaking. So yeah, you could do a lot of this with DuckDB. And then I think that's basically it for that. Oh, question was asked earlier about speed of orc versus Protobuf. I bet I have that. Or no, orc versus Parquet. So it looks like, at least in my benchmark, writes a little bit slower in Parquet, reads a little bit faster in Parquet, and I'm not querying for orc. But again, they're relatively comparable. They're both in the same ballpark. And I think that's it. Any questions? Yeah.
Any other questions?
Yes. Yeah. So really, that's why this format and all the other formats are so good. That's one of the reasons. CSV and JSON, you spend most of your time just parsing text, and that takes forever in terms of CPU time. So if it's already an int or already a byte, you can just, it's much easier to just pull it out and use it. Which again goes back to cost. If you're spending all your time parsing text, you're wasting CPU all the time. Speaking of that, I think I didn't mention it earlier. There is a library. If you really must use JSON, you might consider trying Zstd JSON. It's created by a professor in Canada. Basically, Zstd again is single instruction, multiple data. It parallelizes the work for parsing JSON, and he does all kinds of black magic to make it really, really fast. And it's written in C, but there's ports to other languages as well.